8-6 part 2, we're going to solve rational inequalities today. So I've got 3 steps to help you through this process. The first thing that you want to do is state the excluded values, because when we're solving an inequality, we're not just getting one solution or one number here, we're getting an entire interval of solutions using the greater than or less than signs, of course. So certain values are excluded in those intervals, mainly the ones that make the denominator 0. So I'll just make that little note here. Denominator, the bottom of your fraction I'm talking about here, cannot be 0. Okay, so those are your excluded values. Then step 2, solve the related equation. You don't need to work with the less than or greater than sign. You can change it to an equal sign and just solve that equation. This will give you another part of your solution region. So then you want to test values on the number line to determine your solution interval. We've done something like this before back in chapter 7, so I'm going to go through that again with you. Okay, so I don't know why this says example 3, but we'll go with it. Solve the inequalities. I think it's because it picks up from the part 1 notes. So first thing we want to do is state the excluded values. I'll do that up in this corner here if my pen works. There we go. So step number 1, what values are excluded? Take a look at your denominators here, 4a and 8a. There's one excluded value, and that's 0. If I plug in 0, I have denominators of 0, and we can't divide by 0, so step 1a cannot equal 0. Step 2, now we're going to solve the related equation, and the related equation is 1 over 4a plus 5 over 8a equals 1/2. Just change the symbol into an equal sign. We're going to get our value of a here. Okay, so remember how to solve these. We want to eliminate the fractions, cancel out each denominator. So what is my lowest common denominator? In this case, it's 8a. If I multiply everything by 8a, I'm going to cancel out 4a, 8a, and 2. So here's what it looks like. Multiply by 8a. Multiply by 8a, and multiply the last fraction by 8a. Okay, so let's do some canceling. The a's will cancel out, and 4 goes into 8 twice. So in this first fraction now I have 2 times 1, which is 2. Plus 8a and 8a are going to cancel out, so that just gives me 5. Equals, on the other side, I'm just canceling out the 2 and the 8. 2 goes into 8 4 times, so I have 1 times 4a, and that gives me 4a. So now my equation is 7 equals 4a, divide each side by 4, and I'm going to leave it as a fraction. A equals 7/4, okay? Or you could say 1 3/4, 1.75, whatever you want to say. So I'll change this into a decimal, I guess, for some of you who like decimals. Okay, so now we've solved the related equation. Our last step now, step number 3, is to test some numbers on the number line to see where our solutions actually are. Okay, so you make your number line. This is step number 3 now. On your number line, you want to include the excluded values. So remember, we cannot have 0. Basically, that's going to be not a solution, not part of your answer. And then 1.75 was the solution to our equation. Let's figure out where these solutions actually are. We need to test a number in each interval. Okay, so I'm talking about to the left of 0, in between 0 and 1.75, and then beyond 1.75. So I'm going to start by testing -1. Let's see what -1 gives us. If it's not a solution, then everything to the left of 0 is out, not a solution. So let me test -1 here. Is 1 over 4 times -1 plus 5 over 8 times -1 greater than 1/2? You're asking yourself this question. So I've got -1/4 plus -5/8. 2 negatives are not going to be greater than +1/2, so the answer is no. So I'm going to cross out this part of the interval. Those are not solutions. I know 0 is not a solution, but maybe there's an open dot there. I need to check a number now in between 0 and 1.75. I'm going to check 1. All right, so same process. Sorry if this gets sloppy. Now I'm checking 1. plugging it in for a. So 1 over 4 times 1, that's 1/4, plus 5 over 8 times 1, that's 5/8. Is it greater than 1/2? Question mark. Well, 5/8 already is bigger than 1/2. So if I add a fourth to it, I'm definitely greater than 1/2. So my answer is yes, yay. These are solutions. So I'm going to put an open dot here, and I'm going to shade in the middle here. Now, I'm going to stop at 1.75. Do I put an open dot or a closed dot on 1.75? Well, 1.75 was the solution here. So when you plug it in, you're going to equal 1/2. But look at my symbol. It's greater than 1/2, not greater than or equal to. So because of that symbol, the greater than sign, I want to use an open circle. And now let's check if anything beyond 1.75 works. Maybe this shading continues. Let's see. If I plug in 2, let's see what we get. So I've got, let's see here, 1. I'll draw a line here. I'm plugging in 2 now for each a. 1 over 4 times 2, that's 1/8, plus 5 over 8 times 2, that's 5/16. Is that greater than 1/2? So I've got 1/8 plus 5/16. You could do this really quickly on your calculator. See if you get a number bigger than 0.5 or 1/2. We actually get 7/16, which is just a little bit less than 1/2. So the answer is no, it's not greater than 1/2. And everything to the right here is also out. So now you've got your solution, and we can write it using either interval notation, or we could write it using an inequality. Here's 2 ways to write your answer. You could say that a is in between 0 and 1.75, or you could write it in interval notation by saying that we've got the interval of solutions from 0 to 1.75 with parentheses to show that they're open dots on those numbers. Okay, let's go through a couple more of these. I'll run through it just a little bit faster. So step 1, state the excluded value. B cannot be 0. Because if you plug in 0, your denominators are 0, we can't have undefined values. Okay, so step 2. Let's solve the related equation. 1 over 3b minus 2 over 5b is less than 1/15. Or actually, let's make it equals, because we don't care about the symbol right now. Okay, so I need to multiply by the lowest common denominator, and if I multiply everything by 15b, I'm going to cancel out each fraction. So I'm going to multiply this one by 15b, this one by 15b, and over here by 15b. Okay, so 15b divided by 3b gives me 5. 5 times 1 is 5. Minus 5b goes into 15b 3 times. The b's are going to cancel out, and I get 3 times 2 or 6. Equals, here the 15s will cancel out, and I'll have a 1b, or just b. So we actually get our solution very quickly here. 5 minus 6 is -1. -1 equals b. Okay, so when I make my number line, step 3, make your number line to figure out where your solutions are. I need to put -1 on the number line because that's the solution from the inequality. And then I need to put 0 on my number line because that's an excluded value. We can't have 0. And now what we're going to do is test a number in each interval. I've split the number line into 3 pieces. To the left of -1, in between 0 and -1, and to the right of 0. So let's test some values here. First number I'm going to test is -2. And I'm going to plug it into the original inequality here. So -2 goes in for each b. 1 over 3 times -2 minus 2 over 5 times -2. Is it less than 1/15? You're asking yourself that question. Okay, so what I have here is -1/6 minus -2/10 or 1/5, I guess. I'm just going to reduce it right away. This becomes a plus sign. Is it greater than 1/15? I don't know. Well, let's get a common denominator here. If I multiply this one by 5 over 5, I have -5/30. Plus, I'm going to multiply this one by 6 over 6, 6/30. That gives me 1/30. Is that less than 1/15? Yeah, it definitely is. 1/30 is a much smaller piece of the pie than 1/15 is. So I'm going to say yes, Negative 2 is a solution, so everything over here will be a solution. Now, when you get to negative 1, you got to ask yourself, I know negative 1 works in the inequality here, but again, it's not equal to. So if I plug in negative 1, remember it's going to equal 1/15. That's what we solved before, but I want to use an open dot on negative 1 because it's strictly less than. It's not less than or equal to. Now I need to check a number in between negative 1 and 0. I'm going to check negative 0.5. Okay, so doing all of our math again, I'm going to plug in negative 0.5 for each b. So 1 over 3 times negative 0.5 minus 2 over 5 times negative 0.5. Is it less than 1/15? Question mark. So again, you can do this pretty quickly on your calculator. What you're going to have here is negative 1 over 1.5 minus negative 2 over 2.5, kind of weird math here, but we're going to add these up. Is it less than 1/15? In this case, the answer is no. It's not, so we know that the solutions in between negative 1 and 0 are out, and now I do need to test a point to the right here because we could have solutions to the right of 0. So now I'm going to test 1, and then we'll finally be done. Where am I going to do this? Well, I'm going to squeeze it in right here. Sorry that this is so messy. Okay, so now I'm testing 1 for b to see if those solutions are, or those numbers are solutions. So I've got 1/3, because I'm just plugging in 1 for b, minus 2/5. Is it less than 1/15? Well, let me get a common denominator of 15 here. First fraction I'm going to multiply by 5 over 5. Second fraction I'm going to multiply by 3 over 3. And now I've got common denominators of 15. So I actually get negative 1/15. Is it less than positive 1/15? No, so I know that these solutions are out, and my answers are just the numbers less than 1. So now I would say b is less than negative 1, or you could say we've got the interval from negative infinity to negative 1. However you want to write it. I don't care if you write it in interval notation or using an inequality. Okay, video is getting long, but I'm going to show you one more example here. Let's start with the 3 steps. Step number 1, state the excluded value. This time x cannot be 1, because if you plug in 1, you'd have 1 minus 1 or 0. So x cannot be 1. Now let's solve the related equation. 1 plus 5 over x minus 1 equals 7/6. I'm going to multiply everything by 6 times x minus 1 because that's going to cancel out each denominator. So 6 times x minus 1 times 1 plus 6 times x minus 1 times 5 over x minus 1, those are going to cancel, equals 7 times 6 times x minus 1. Every fraction or every part of the equation has to be multiplied by the same thing. Okay, so now what do we have? I have 6 times x minus 1 plus the x minus 1's cancel out, and I have 6 times 5 or 30 equals, on the other side here, the 6's will cancel out, and I'll have 7 times x minus 1. Okay, so let's use the distributive property. I have 6x minus 6 plus 30 equals 7x minus 7. Put my like terms together, negative 6 and 30 gives me 24. So 6x plus 24 equals 7x minus 7. I'm going to continue to solve here for x. So let's get the x's on the same side. Take away 6 on each side. 24 equals 1x minus 7. Now I just have to add 7 to each side, and I get x equals 31. Okay, so now I've got 2 values to put on my number line, 1 and 31, and I need to test some points in between those numbers. So step number 3, make your number line and test some solutions. Here's 1, here's 31. Let's go ahead and start. I'm going to start by testing 0, because that's an easy number to plug in. So 1 plus 5 over 0 minus 1, is it less than or equal to 7/6? 7/6 is 1 1/6. So I have 1 plus this is 5 over -1 or -5. Is that less than or equal to 7/6? Definitely not, because I get -4, not less than or equal to, so this is out, no. I know 1 is not a solution, so I have an open dot there, but I need to check now to see if anything to the right of it is a solution. So is 2 a solution, or anything in between 1 and 31? You only need to test 1 point. So I'm going to check 2 for x. 1 plus 5 over 2 minus 1, is that less than or equal to 7/6? So I have 1 plus 5, 2 minus 1 is 1, 5 over 1 is 5. That's 6. Is 6 less than or equal to 7/6? Definitely not. This is 1 and 1/6. 6 is way bigger, so 2 is out. I know 1 is out, so really everything in between, or everything in between 1 and 31 is out. Now, 31 is a solution, so I'm going to put a closed dot there. Think about this. How do I know 31 is a solution? Well, when we solve the equation x is equal to 31, I do have an equal sign this time underneath my less than sign, less than or equal to. So if I plug in 31, I'm going to get 7/6 is less than or equal to 7/6. That works. I'm hoping that these numbers to the right will work. So let's plug in 32 for x. So I have 1 plus 5 over 32 minus 1. Is that less than or equal to 7/6? 1 and 1/6. Well, I have 1 plus 5/31. Is that less than or equal to 7/6? Well, I would say 1 and 5/31 is less than or equal to 1 and 1/6. How do I know this? Well, 1 and 1/6 is 1 and 5/30, and I know that 5/31 is smaller because it's got a bigger denominator. It means the pieces of the pie are smaller. So yes, this is true. So anything to the right of 31 is a solution. So now I would say x is greater than or equal to 31 using the inequality sign, or if you want to use interval notation, you would say our solutions are, using a bracket, 31 to positive infinity. Okay, now the video is done. You're going to try some of these in class.